You know when you look at a circuit board, say inside your phone, and it just looks like magic? All those tiny little components, it seems impossibly complicated. But what if I told you that underneath all that complexity, it's all governed by one surprisingly simple rule? Okay, let's jump right in.
So how do we even start to wrap our heads around this? Well, it all starts with a brilliant analogy. Think of electricity like water. The voltage? That's the water pressure from the tower. The current? That's how fast the water is actually flowing. And resistance? Well, that's like pinching the hose. You know, more pressure means more flow. A tighter pinch means less flow. It's really that simple. And for this explainer, we're going to be using some fantastic resources from electronicsed.com to really make these ideas stick.
So what is this secret rule that holds all of this together? It has a name, and it's called Ohm's Law.
And listen, when I say it's the backbone, I am not kidding. It doesn't matter if you're an engineer with decades of experience or just tinkering with your first project. This single formula, it's the key to understanding pretty much any circuit you're ever going to see.
Now this triangle here, this is your secret weapon. Seriously, it's such a powerful little memory tool. All you do is cover up the thing you want to find. Need the voltage? Just cover the V and you're left with I times R. Need to find the current? Cover up the I, and you see it's V divided by R. It's awesome. If you know any two of these, you can find the third in a heartbeat.
Okay, so let's get our terms straight real quick. Voltage, we use a V for that, is that electrical pressure, and we measure it in volts. Current, with the symbol I, is the actual flow, measured in amps, or you'll just hear amps. And finally, resistance, R, is whatever is pushing back against that flow, and we measure that in ohms.
All right, enough theory, right? Let's get our hands dirty and actually put this amazing tool to the test. You're about to see just how much you can figure out with one simple formula.
So here we go. It really doesn't get much more basic than this. We've got a power source, a battery, giving us 12 volts of push, and we have one single resistor giving us 4 ohms of pushback.
So here's the question for you. Look at that Ohm's Law triangle we just talked about. How much current, how much flow is actually moving through this wire? What's the calculation you need to do?
Got it? If you said we take the voltage and divide it by the resistance, you are absolutely correct. 12 volts divided by 4 ohms gives us 3 amps. See? Easy. And this kind of quick, simple math is what all of electronics is built on.
Okay, that was level 1. Let's kick it up a notch. What happens if we start stringing components together, one after another? Well, that's called a series circuit, so let's check it out.
Now, in a series circuit, all the parts are chained together, one after the other. And this is the most important part to understand. It means the current has only one path. It's a one-way street. It has to go through every single thing in its path.
To figure this out, we just need a simple 3-step game plan. First, we'll just add up all the resistance to get one big total. Then, we'll use that total to figure out the single current that's flowing through the whole loop. And last, we'll see how that main voltage gets shared, or dropped, across each resistor.
So let's run the numbers. As you can see, finding the total resistance is a piece of cake. We just add them up. 3 plus 4 plus 5 gives us 12 ohms. Now, we use Ohm's law on the whole circuit. 60 volts divided by our 12 ohms total gives us 5 amps. And remember, because it's a series circuit, that same 5 amps flows through every single resistor. So now we can use Ohm's law on each one to see how much voltage it uses up.
And this is where the real magic happens. Notice anything? If you take those individual voltage drops, 15 volts, 20 volts, and 25 volts, and add them up, you get 60 volts. Exactly what we started with. The battery's voltage is perfectly shared among all the parts. This is actually a perfect illustration of another big rule called Kirchhoff's voltage law.
But what happens when the current gets to a fork in the road and has a choice of which way to go? Well, that brings us to the other common setup, the parallel circuit. Now, take a close look here. This is totally different. In parallel, each resistor gets its own direct connection to the power source. This means 2 critical things. First, the voltage is the same for every path. But second, the current now splits and goes down each path separately. So the trick here is to just treat each branch like its own little mini circuit.
We just apply Ohm's law to each path, one at a time. For that first branch with the 3 ohm resistor, 12 volts divided by 3 ohms is 4 amps. For the second, it's 3 amps. And for the third, it's 2 amps. Simple as that.
So, what's the total current that has to come out of the battery to feed all these paths? Well, we just add up the flow from each one. 4 plus 3 plus 2 gives us a total of 9 amps. And just like before, this shows us another fundamental law, Kirchhoff's current law, which basically says that whatever current flows into a split has to equal the total current that flows out. Nothing gets lost.
So let's just pause for a second. In just a few minutes, we've gone from one simple formula to being able to analyze the 2 most common types of circuits out there. Let's pull this all together into a toolkit.
Here's the most important thing to remember. Ohm's law is your go-to for zooming in on one single component. It tells you what's happening right there. But when you zoom out and look at the whole network, all the loops and splits, that's when you use Kirchhoff's laws to understand how the entire system is behaving.
So why do you care about any of this? Because with what you've just learned, you're not just staring at lines on a page anymore. You can actually predict how much current will flow. You can pick the right resistor to make sure you don't burn out an LED. You can design your own simple circuits. You can even start to troubleshoot when things go wrong. You now speak the language of circuit.
So that's the big picture on Ohm's law. You now have the fundamental key that unlocks the world of electronics. So the only real question left is, what are you going to build? Or what are you going to finally understand with it?